When you think of STEM, do you think of geology? Most people don't. It's effectively a forgotten member of the STEM family. With no Nobel Prize and no high school requirement, geology often goes overlooked and underappreciated. All this despite geology being the study of our own planet. Did you know that surface maps of Venus and Mars are around 100 times more detailed than maps of our own ocean floor? And what if I told you that we could take the carbon that's polluting our atmosphere and turn it into rocks at the bottom of our ocean? This is called silicate weathering. Silicate weathering is a natural process that starts up in the atmosphere, where carbon is floating around in the form of carbon dioxide gas. This gas reacts with water molecules to create a weak acid called carbonic acid. When the acidic water falls to the surface in the form of rain, it carries the carbon with it. And when the rain falls onto silicate rocks, the carbonic acid chemically weathers the rock, breaking it down into cations, clay minerals, and most importantly, carbon in the form of bicarbonate. In this example, I'm using the silicate rock wollastonite, which produces calcium cations. All these ions, or charged particles, get flushed out into the ocean through river systems. As these ions react with each other in the ocean, some 50% of the carbon is converted into calcium carbonate. The calcium carbonate from this reaction is then used by shellfish, snails, and other marine calcifiers to make their shells. Once these organisms die, they slowly filter down and settle onto the bottom of the ocean, where they eventually turn into rock or become lithified after being buried under layers of ocean sediment. Overall, through this reaction, carbon is wrenched from the atmosphere and locked in ocean sediment, where it is stored for thousands of years. This weathering process represents a substantial reduction of atmospheric carbon that could be even more effective when combined with reducing emissions. So, silicate weathering could be a key weapon in the fight against climate change. But it's a very slow geologic process that takes millions of years. Enhanced silicate weathering operates by accelerating the chemical breakdown of silicates, making this process a viable climate solution on human timescales. It functions through the application of finely ground silicate rock powder, which has a much higher surface area and therefore a much higher rate of reaction. In practice, silicate rock powder can be applied to agricultural soils, which presents an opportunity to sequester carbon on a large spatial scale. Learning to read the language of geology is critical in understanding the consequences of our actions on this planet. Now is the time to take control of the way we write this language. Enhanced silicate weathering just might be our pen.